very lecture is aimed for explaining the some of the explanation behind the structure of the glucose. But in order to start, I have to draw the structure back again. So what I'm going to do, I'm going to draw that glucose molecule again, and then I will explain one by one what this is. So like we had, we were to do the glucose structure. Like I remember, I have already explained you that a glucose molecule has this kind of structure where the first carbon is in the form of aldehyde and rest of the carbons are in this particular manner. The last one is in the form of CH2OH. The second carbon has a hydroxide group on the right hand side while there is a hydrogen on the left hand side, and the next one has a hydrogen and then there is hydroxide, and remaining two has two hydroxide on the right hand side. So overall there are 3 hydroxide on the right hand side. So this is something I have already explained to you, right? Now the question is, why is glucose having this structure, and is there anything significant related to the structure? So the first thing about this structure, I have in my mind is that why the formula of glucose is C6H12O6. So the first one is its formula C6H12O6. Now let me explain you why this formula and how this formula even came. Suppose you have a sample of glucose in the form of a powder, and you let the powder of your organic compound undergo combustion. And as you remember, or probably you know, that when an organic compound undergo complete combustion, it produces carbon dioxide and water. Now what you had a powder, you let it undergo combustion, and then you produce a certain mass of CO2 and a certain mass of water. Using the mole concept, we can find out the empirical formula from those two amount of water and CO2. So for what we did, we found the empirical formula of the organic compound, and then we will be able to find out the molecular formula as well. So the first information about glucose is that it has a formula of C6H12O6 is coming from the mole concept and empirical formula concept, right? So this is the first information, and this is what comes from mole concept. It comes from mole concept, right? And like I said, empirical formula concept also. So I'm going to write here, and empirical formula calculation. Empirical formula calculation. So from this method you came across the formula of the glucose. Now let's talk about the second important thing about the glucose and what that is. If you remember, we can make it this formula in a very simple way, and this is going to be like CHO, and then you have CHOH whole 4. What I'm doing here, 1, 2, 3, 4, they can be represented in short, and the last one you have CH2OH. So this is the condensed formula of your glucose. Now what you need to do, you have to do prolonged heating. You have to do prolonged heating. In presence of HI. And what this is nothing but a reducing agent. So what this is your reducing agent. Okay, let me repeat back. We are conducting a reaction where the glucose is being heated for a long time, in presence of hydrogen iodide, which is nothing but a reducing agent. So what will happen, just because this is a reducing agent, this will take up all the oxygen and will add more hydrogen into that, and as a result, this glucose will convert into hexane. So this is, coming out to be like hexane. So this is what your hexane looks like to be. What we can do in short, we can write C6H14. So what is the conclusion coming from this reaction is that, glucose is a 6-carbon molecule where all the carbons are in straight chain. right? So this reaction was to aim, and this reaction was to prove that all the carbon present in the glucose, they are in linear, arrangement. So this is the purpose of second reaction we have, right? Now let's go with the third one. Now what this third one is, that is very, very important here. So our third reaction is also, to tell you something very important about glucose. So this is what your glucose looks like in condensed form, right? Sorry. Okay, and then we have, CH2OH. So this is your glucose. Now what you have to do, I'm, making you go with two reactions. The first reaction is with the NH2OH. The first reaction is with NH2OH. So this is the NH2OH we have. This is what the structure is. Now, if you pay attention here, this aldehyde is in the form of, this kind of a structure. So what it looks like, that if these two hydrogen can come out, this will result formation of a water molecule. So this is coming out to be carbon, this is coming out to be carbon. You have, your double bond, nitrogen. Nitrogen is then with the hydroxide, and you have your hydrogen back here. And what you have again, the remaining part, which is CHOH whole 4, and then you have CH2OH. Now this compound is called oxime. This is called oxime. Now concentrate here. What we did, we actually reacted the glucose molecule with NH2OH, and what happened, both of these underwent some interaction and produced a byproduct molecule or a leaving group called water. And after the water is released out, they form a complex, and that complex is called oxime. So what this reaction is proving, that's very important, is that, the first carbon has a carbonyl group. The first carbon is in the form of carbonyl group. Let me repeat back. The first carbon is in the form of a carbonyl group. So this reaction is, basically to prove that the first carbon is in the form of a carbonyl group, right? So that's what the purpose of the reaction is. Now, I have to do one more reaction, and that reaction is also going to be for the same purpose. And what that reaction is, I'm putting them right here. I have enough space left. So this is also the third one. Right? This is like A, and this is going to be the B part here. Now, I'm taking again, this aldehyde here. This is your aldehyde, and you have then CHOH, with a whole 4. And finally you have CH2OH, right? So what happened when you react this molecule, just pay attention here, when you react this molecule with hydrogen cyanide, what is happening here? This is your electrophilic center, and this is your nucleophilic center. So what will happen? This cyanide will attack to the carbon, but in order to do so, one of the bond will go back to oxygen, and in that case oxygen will take, this hydrogen will go with the oxygen, and cyanide will go with the carbon. So you are able to form your another product, which is going to be C. You have your OH here, and then you have your H here. I'm placing the cyanide right here, and rest of the thing as usual, CHOH whole 4, and along with that you have a CH2OH. And what this is called? This product is called cyanohydrine. This is called cyanohydrine. Right? So this is also for the same purpose, which proves that the first carbon is in the form of a carbonyl group, right? That the first carbon has something to do with the carbonyl group. So what we did 4 of the very important, properties about the glucose structure, right? The first was to make sure that this formula is C6H12O6. Second was to prove that all the 6 carbons are in straight chain. The third one was, which has a 2-part, and both of these reactions are to prove that the first carbon has nothing but a carbonyl group. So this carbonyl group is identified by these 2 reactions, where one of the product is called, this was called your oxime, and this was called your cyanohydrine. So there are a couple of more reactions coming up, but I will do that, in the next lecture. I would say thanks for watching, take care, and just pay attention, because this is really something important, right? There are more to come, and take care and good night.